Hello everyone. Today we are going to work on solving for like a different value in the exponential growth and decay functions. We did a little bit of this already when we tried to figure out how long it would take for a population to reach a certain amount by guessing and checking. That's one of the things we'll do. So here's your learning targets, the homework, etc. Let's just go right into it. So here's what we're going to do. To find like an initial value that you need to start with in order to get a final amount, what we're going to do is we're going to substitute all the information into the equation that we need. And then we're going to simplify the parentheses that's raised to a number so that we get just a decimal number. And then we're going to divide each side of the equation by that new value. So we're basically just using algebra. Okay, so it says, suppose you want to buy a car 4 years from now. How much money would you need to deposit into an account that is guaranteed to increase at a yearly rate of 7% to have $15,000 at the end of all of it to buy the car? So this is our growth because it's increasing. So basically our basic formula is y equals a times 1 plus our rate that it's changing per year for the time. So then what happens here is the 4 years is what goes in for time. We're going to let this grow for 4 years. So now we're going to have 1 plus our rate. Okay, our rate is, it's increasing at 7%. So that is 0.07. We don't know what our A value is. That's what we're trying to find. How much would this A value have to be so that when after 4 years, we would have this $15,000. So that's what we're going to do. We're going to plug all the values in, and now we're going to work the algebra. So what we're going to do is we're going to take this part right here, this 1.07, and raise it to the 4th power, and we're going to get a decimal. Okay, and when we do that, we're going to get a really long decimal. But we're going to plug it in right here. And this is going to be A times 1.310799601. Okay? And that's going to equal $15,000. Now, if you keep that long decimal in your calculator, that's going to give you a slightly different answer than if you round. This is going to be the most accurate if you divide by that whole decimal number. But most of us are probably going to be not wanting to do that. So we're going to round that number. And the more decimal places you keep, the more accurate your answer will be. I'm going to try to round it to like 3 or 4 decimal places. So 1.311. So now all I have to do to solve this is divide each side by 1.311. And that gives me a value of A would have to be $11,441.65. So that's how much I would have to invest or start saving in order to get $15,000 in 4 years. So that's what we're doing. We're solving for A, and eventually here we're going to solve for T. Okay, here's another example. It says, the value of a painting is right now $150,000. Suppose that its value had been growing at a rate of 8% for 5 years. What was the value 5 years ago? In other words, what was that initial starting value right there? So that when you take 1 plus your rate of 0.08 and it was growing for 5 years, that it would equal 150,000. Okay, so there's your sort of equation to solve. So now let's just go ahead and do what I said before, is let's get a decimal right here for this value. So just type in 1 plus 0.08, hit equals, or just 1.08, raised to the 5th power. And what that's going to give you is, again, a long decimal. We'll round it, 1.469 times A equals 150,000. So now I'm going to divide each side by that decimal, 1.469. 1.469, and that gives me a value of A would be, the painting was worth $102,110.28. So again, this answer right here that we're getting is going to be slightly different depending on this value right there, depending on how many decimal places you use. So keep that in mind as you work through the examples and check your work, or when you work through the homework and check your work, that it might be slightly different. So check the key, make sure you see the differences and that you're doing it right. So now let's look at solving for t. Okay, to find a t value, we're going to substitute all the information into the equation, and then we're just going to basically guess and check values for t until we find the value. Okay, so suppose the population of a city was 200,000 in the year 2006, and it's decreasing at a rate of 2% per year. When will the population of the city be less than 175,000? So I don't know the final amount. I want to know, when is this going to equal 200,000? Oh, sorry, when is it going to be less than 200,000? Right now it is 200,000. Let's just go in order. And we know that it's decreasing, so it's the decay 1 minus the rate, and the rate is 2% right here, so 0.02. I don't know how long that this is going to be going on, but I know that I want it to be less than that 175,000. So basically I want it to equal 175,000, but I want it to be less than that. So I'm just going to guess and check some values of time. Okay, so what if t is equal to, let's say 10, for example. Okay, so then I would put a 10 right here in for t. Okay, and so that would look like 200,000 times 1 minus 0.02 to the 10th power. And what that gives me is 180, so 1,000. So it still hasn't gotten down low enough. So then maybe I can guess another value of t. Let's say t is equal to 8. Let's try 8. See if that works. Well, if I plug all that into my calculator, again, you might want to pause the video and see if you're getting these answers correctly on your calculator. But after 8 years, now the population has dropped well below. It's 170,152.6. So now let's guess another value. Let's try 7. Well, 7 is 173. 625.11, and I'm still below, but I don't know if that was too much, so let's try 6. Now that's 177, 168.48. So it gets below 175,000 between 6 and 7 years, so somewhere in between. And we could be actually more accurate if we really wanted to know, and we could actually guess what if t was like equal to 6.5, but we're not going to get too crazy guessing decimals. So just get between 2 years and that will be enough. So that's basically it. If you feel confident, you can go to the homework now. I'm going to work through this one last example here on the video. If you'd like to see another video or example, then stick around. Otherwise, you can move to the homework. Have a great day. All right. The population of Mathtown is 1,500. It's growing by 1.2% each year. How long will it take the population to grow? We want it to be 200,000. So it's growing, okay? So that means it's going up. So that means we're going to have 1 plus our rate of change. And our decimal here is not 1.2. Remember that 1.2%, we have to move it over 2 places. So that's going to be 0.012. We don't know how long it's going to take, but we know right now it's 1500, and we want this to equal 2000. So let's guess and check some years. Well, if I start with t equals 10, and I put this 10 in here, calculate it out, that gives me 1,690 people, approximately, not enough. So let's guess 20. And that gives me 1,904, got closer. So let's guess 25, because we're still not there. We want it to be 2,000. So that yields 2021.18. And if we want to like see if we're closer, let's try 24. If we plug in 24, we get 1,997.21. So how long will it take it to grow to 2,000? Well, it has to be about 25 years, because 24 does not get it to that 2,000. All right, guys, have a good day.